Okay, continuing on with our last example. It says a plane is flying north 30 degrees east at 500 kilometers per hour. So let's draw a picture of that using the quadrant bearing. Okay, so here's north, east, south, and west. So our plane is flying north 30 degrees east. This would be much better with a ruler, but I can't really do that with my iPad, so we'll just do our best. So north 30 degrees east would be about there, and the magnitude of that velocity vector is 500 kilometers per hour. Now, it says a wind of 80 kilometers per hour is blowing due west. So at the same time, we have this wind, which has a magnitude of 80 kilometers per hour. And we have to find the resultant velocity of the plane relative to the ground. So obviously the wind speed and direction has an effect on the resultant velocity of the plane. So we're going to use our parallelogram law here. And we're going to slide the wind vector up to the top so that our two vectors are placed head to tail. And then our resultant vector will be this vector here that goes from the origin to the end of that vector that I just translated. So this will be our resultant vector that we'll label with an R. Okay, so now the problem being that in our triangle, which now we're looking at this triangle here, we don't have any of the angle measures. But what we can do is we can use the fact that we know the plane was flying north 30 degrees east to find the measure of this angle at the bottom, which would be 60 degrees, because of course those two angles are complementary and they add up to 90. So if that angle is 60 degrees, then using your Z pattern, this angle at the top is also 60 degrees. So we're getting a lot written in this one little picture. So I'm going to redraw this triangle off to the side. Okay, to give you a clear idea of the numbers we're looking at here. So we just said this angle at the top is 60. This is our resultant vector that we're looking for. That is supposed to be an R. There we go. This side is 500 kilometers per hour. That's your velocity vector for the plane. And what am I missing? Oh, this vector at the top is 80 kilometers per hour. Okay, so once again, this is a cosine law situation where we have two sides in the contained angle, and we're looking for the measure of the third side. So we would say the magnitude of the resultant squared is equal to 500 squared plus 80 squared minus 2 times 500 times 80. Whoops, that's supposed to say 80. Times the cosine of 60 degrees. Type all that into your calculator. We'll get R squared equals 216,400. And when you take the square root, you get the magnitude of the resultant vector, which is 465 kilometers per hour. So therefore, the resultant velocity of the plane relative to the ground is only 465 kilometers per hour, because the wind, of course, is slowing it down a little bit. And that concludes this lesson.